Is this just the, I think we had the 23 pure paper.
Yeah, so there's
Yeah.
two papers for the 23. So did you see
I
this
don't, I
question?
don't, I don't think we saw that
Yeah,
exact
so
question.
they might have just chosen one paper. Oh, here she is. Here.
Yeah.
Okay. So, hi there, Ink. Have you joined us? We're just going to start with that question that you'd sent. So, I think you'd sent it last week sometime. You had a go at this one. It's from the 2023 paper. Yeah, so if you've got some pen and paper, yeah, so this is question 15. So getting on to the longer questions. I'm not sure. I think there might have been 16 questions in total. Remember, there was 16 questions. I do remember last year that they'd stuck to what they said because they brought out some information in October, December to say that they would try and make the questions more accessible. They would have show that question so that it was there to see what you meant to get for part A, and if you couldn't get that, then at least you'd have it in part A to go on to do part B. And they would try to have easier questions at the beginning. I remember one of the papers, like the hardest question was the second to last question, and then the actual last question was quite straightforward. So they'd even been a bit nice right at the end if people had got there. But I think they were quite long papers. Just remember, top of my head, people moaning after paper one, paper two was a bit better, or the other way around. I can't remember. Right, so we've got this one here, which has got a curve. Show that f dash. So we've got a quotient here, so we're going to be using the quotient rule, but in the numerator, we have also got a product, so we're also going to be using the product rule. So if we first of all write f of x and I have it as 7 x e to the x over, and then write the denominator as a fraction to the half, and then let's start doing f dash. So when I'm doing the quotient rule, you do get that on the formula sheet, so it's v du by dx minus u dv by dx all over v squared, but I just remember it as bottom, which is the v e to the 3x minus 2 to the half, differential of the top. Now, differential of the top is a product, so we have to use the product rule. So we need brackets because when I start to differentiate this top, it's going to have two terms. And the product rule, I do first, differential of second, e to the x differentiates to itself, plus second differential of first. Differential of first is 7 e to the x. So that will be bottom differential of top minus top 7x e to the x differential of bottom. Now, differential of bottom, I'm going to power down and then leave alone and then take one off. So just left some room, and then we're all going to be over bottom squared. Now, because we've got this square root, we're just going to go e to the 3x minus 2, and then squaring it will just get rid of that square root sign. Everyone happy so far? Yeah. So having a look at where we're going, we can see we've got this in the denominator, so we need to add some bits in the denominator. And the first thing I can notice here where I'm going, they've taken out, because we've got brackets around all of that, obviously we've got to find the a and b, they've taken out this 7 e to the x. So having a look where you're going is a good thing. Now I have got a 7 e to the x, a 7 e to the x, and a 7 e to the x in all of the terms. Because these ones in the bracket are both multiplied by this bracket, I can just take them out of both of those two terms on the top. Everyone with me? So I'm going to go 7 e to the x, and then I'm going to do my e to the 3x minus 2 to the half, and then I've taken 7 e to the x, so I'm going to have an x minus 1 minus, I've taken 7 e to the x, so I've got x over 2 e to the 3x minus 2 to the minus a half. And then that will all be over that common, denominator. sorry, and that should be +1 there because it's plus there. Everyone with me so far? And what's the next?
When you differentiated your e to the 3x minus 2 to the half, is that chain rule as well? Do you have to take the differential of the inside as
Oh
well?
yeah, so I'm missing a 3
A
e to
three.
yeah, it's because I'd run out of room there. I'm missing a 3, so we should have at the end here a 3 e to the 3x. Yeah, carried away there. Yeah, sorry on the top. So thank you, Ritesh. What should we have a look at doing next? We've got to somehow try and get on the bottom more of the e to the 3x minus 2. So then I've got the 7 e to the x on the front. I've got this term and this term, which have all got something in common, the e to the 3x minus 2 to the half. Now, when you're taking things out to a power, you look to what's got the lowest half. So on the front, if I put 7 e to the x, which I've got, and then have an e to the 3x minus 2 to the half, and then take that out as well, then I will have, sorry, to the minus a half. And then what I'll need to do is have this to make that half. I'll need to have e to the 3x minus 2 to the 1, and I'll have the x plus 1. And then I've taken that out. I'll have the minus 3x over 2, taken that out, e to the 3x. We've still got that on the bottom. Everyone with me still? Yeah. And then what I can do with the e to the 3x to the minus half, that on the front can come on the bottom. So this to the minus half can take that off there because I'm going to run out of space. And then this can join in because on the bottom that will give me a 3 over 2 because that's the minus half, which will on the bottom be a half, which will join in with the 1. So at least I've got that bit. And I've got that 7 e to the x there. E to the 3x. E to the x.
How did you change the denominator again from that to the power of 3 over 2?
So you've got to the minus a half of that e to the 3x minus 2. The minus means that's just going to be 1 over e to the 3x minus 2. So it's going to put that over. And I already had to the 1, and then I had e to the 3x minus 2 to the half because the minus went on the bottom. And then I've got a half plus a 1. And then that's going to give me 3 over 2 on the bottom. Yeah,
Okay, thank you.
you get that? Yep. We've got everything. Yeah. So what we can do now is that 7 to the x at the big front is all of that numerator. Now let's leave some room. And now these two terms, I can FOIL them out. So we've got 7 e to the x, and then I'm just going to go FOIL these out. So it's going to be x e to the 3x plus e to the 3x minus 2x minus 2, and then I'll have a minus 3x over 2 e to the 3x. So that's just that multiplied out those two brackets. And then here we can see we've got a whole x e to the 3x and minus a half of the same term. See, the term is x e to the 3x, and we've got x e to the 3x. So we've got a whole one minus a half. So that is going to be, so I'm just dealing with the numerator here. I'm going to have a minus a half x e to the 3x. And then I'll have a plus e to the 3x, a minus a 2x, and a minus 2. Now what I can do is see how we've got to get this 2 here. Because I've got a 2 that's joined to this term in the denominator, if I want to take that line all the way along, I can just move that so everything has got a half and just double up these terms. So that will be minus 4x and a minus 4. And now that 2 is all the way along. And then just like we did before when we had something to the minus and we just shoved it underneath to join, that 2, now it goes all the way along, can now just join in here with this denominator. So I'm going to have on the top 7e to the x minus x e to the 3x plus a 2e to the 3x minus a 4x minus 4. And then let's bring the denominator back in. It's going to be 2e to the 3x minus 2 all to the 3 over 2. Everyone with me so far now? Seen what I've done with that 2, taking that all the way along. I had to double all of these terms in order for that line to go all along. And now that 2 can join in. And now we have got the denominator. So what can we do now to try and get what's happening here? Can you see, if I just rub some of this out, we've got this bit on the front, we've got this in the denominator, we've just got to sort out this bit here, and we can see we're heading towards an e to the 3x to come out, and which terms in this bracket have got e to the 3x. So all we need to do is take that out in that term there. So we've got 7e to the x, then we've got our e to the 3x, so that needs to come out, and we're going to have a plus 2 and a minus x, so that will give us a 2 minus x, put it round in the way they want it, so that's all times by e to the x, and then we've got a minus 4x and a minus 4, and that's all over my 2 e to the 3x minus 2 to the 3 over 2. So we've got it now that A and B are both minus 4. Any questions? Has it all got a bit messy because I haven't had enough room there? Everyone with me? Georgie, do you get that?
Yeah.
Yeah, just to see all what it did. So, you know, you've got to be meticulous. You've definitely got to do it right. Ritesh ran out of room there at that beginning. It's all a bit messy, but you've got to keep an eye on where you're trying to go and trying to manipulate stuff. And we could only take that 2 underneath when it belonged all the way along. Okay. Ink, do you understand that? How I've got there? Any other questions on that?
Yeah, everything makes sense. It's just a lot.
Yeah, it's a lot. It's all a bit messy, wasn't it? But yeah. So often when you've got things like this, the actual doing the quotient rule, doing the product rule, they're not difficult. It just depends what functions you've got to do them with. And you've got to be just meticulous, not do too much in one go. Do one thing at a time. It's a bit of pain having to write it all out each time. Like where I was doing that, I'd kind of leave the denominator and just deal with the numerator and then put it all back together because it's a pain to write everything out, to do things one at a time, to work down your page, isn't it? But then always be thinking of where you've got to go to. Right, I've got a bit of room now. So I've got A and B. Part B, hence show that the x-coordinate of the turning point of the curve are the solutions to this. So we're talking about turning points. What are we going to be doing with our f dash? What are we going to be doing with that, Ritesh?
Should you make that equal to 0?
Equal to 0, which is this thing. Now, because it's a fraction, when can they equal 0? Only when the
When the
numerator, yeah, so
numerator equals 0.
yeah, e to the 3x2 minus x minus 4x minus 4 has to equal 0 at the turning point. Now, this thing on the front, 7e to the x, we know that 7e to the x like that, it's never going to go 0. So that part of this is never going to equal 0. So we've just got this bit. And what we can do is multiply that back out again. So 2e to the 3x minus x e to the 3x minus 4x minus 4 is equal to 0. Just multiplying that out and looking at that term that's in the bracket. And then what they do to get to here, you can see there's kind of no x's apart from the ones in the air. So these x's on the ground, they need to be the subject of the equation. So we need to leave the positive terms here, the terms without x there, and take x the other side, so though these terms will be positive. So it'll be x e to the 3x plus 4x. And then let's probably see what we're going to do now. Take that x out as a common factor. E to the 3x plus 4. And then we're just going to cross multiply. So that is what we've got there. So, and getting this here kind of tells us what we got in part A was kind of right, because we've now been able to manipulate it to get the right thing in terms of part B. So our A's and B's, you know, gave us the +4 there and the -4. So they were right in the first place. Okay, so this one here, when it said show that and having the A and B, you couldn't actually get that until you'd got the A and B. So this was a bit nasty of them, and something against what they've said. They said they would have things in the part A in order for you to use them. But if you could manipulate or do anything with f dash of x, I'm sure you would get the method marks, even if you just used A and B as A and B instead of the 4s. Okay, so any questions on that? Are we okay? Getting part B? Yep. And then if you've got part B, you can see we're going to use the iterative formula of getting the next one along as what we do to the ones before in order to get our alpha and betas, which are going to be our roots. And we've got this diagram here. Let's move that out of the way. Which was in the exam script, using a staircase diagram, show for the iteration formula starting with x1 is equal to 1. So alpha and beta are our roots, where we've got our iteration formula and where that equals the lines y equals x, because we've got y equals x and y equals the formula. So when we draw the line y equals x and where that line y equals x equals the iteration formula, these are going to be the roots when we had everything all to one side equal to 0. So that's why you've got that line y equals x on there. Now, alpha and beta are our roots, but it's telling us to use x1 is equal to 1. So what you need to do from x1 is equal to 1 is go up to the curve, feed it to the line y equals x, go up to the curve, feed it, and home in on the diagram to get to the root. Yeah. Then on your calculators, it says use the iteration formula with x1 equal to 1. So we're all okay with using our calculators. You type in 1 equals, and then 1 will go at the bottom of your calculator display. And then if you type all this formula in, but instead of using 3x to the n, if you just write 2e to the 3 and then use the answer, it will feed in whatever's in the bottom of the screen. And then if you keep pressing equals once you've filled all that in, because when you press your first equals, you'll get a new answer, and then you just keep pressing equals and it will home in on the root. So you need to just do that on your calculator and find your x2 to so many decimal places, and then keep pressing until it settles down to 3 decimal places. It stays still, and that will be your beta.
Which mode do you use in the calculator again?
Which what? Which
What
in
mode?
the normal mode? Just go into normal mode and just press 1 equals, and then go to just put a fraction, do 1 equals, so 1's at the bottom of the screen, and then press your fraction button and type all that in. So it'll be 2 and then e to the 3 times answer key.
Oh, okay, so you
minus
just
4, yeah,
type
and then
out the
yeah,
whole
then
equation.
it'll be inverse e to the 3 times answer plus 4 on the bottom. And then when you've typed it all in, you'll just press equals. I'm getting 1.501, which kind of ties in with our first iteration going to here, then reading up to the curve. So the 1.50 will be 1.502 will be there. And then what to do, it's only asking you for the first x2, but now that new number's at the bottom of the screen, when you keep pressing equals, it then refeeds in as the answer, and you just keep pressing equals until you get it to settle down. Now I've pressed it about 10 times and it's settling down at 1.968. So to 3 decimal places, that's what I would give. In part C, it says show using a suitable interval that the function is alpha is a root. So whenever you're doing this, when you've got to go a suitable interval, you go to one more column and you're going to look at 0.4325 and 0.4315. So thinking of that last column as 20 and going half below, half above, and you're looking for a change of sign when you put them in. Now we're looking for a suitable root of the f dash. So you need to go back. So what we've been doing when we equated that equal to naught and got this iterative formula, it all came from f dash. So you need to put in those 2 values of alpha into all this where we got our -4 and 4, not into this, which is what the mistake might be, because that's where your iterative formula had come from. Yeah, and so you'd put those and you would get a change of sign, and then you'd be saying the interval was continuous. A change of sign means that we have found our root, and alpha to 3 decimal places is the 0.432.
Sorry, my Wi-Fi cut out for a second. Where would you put that into?
So you need, so see
No.
how, where's our iteration formula come from? It's come
Yeah.
from when we equated the derivative, the f dash, to equal to 0. So
Yeah.
we are finding roots to what made the derivative 0. So we need to put it back into f dash, not into f, because that's where the iteration formulas come from.
Okay, so you put it in place of
Yeah,
A.
yes, yeah,
Yeah.
and we'd need our 4 and our -4 and -4. The whole point, like when you're trying to find roots, like you're trying to
Yeah.
find roots where the thing that you have plotted, y equals, say, a quadratic, where does it equal 0? Where is y is equal to 0? And see, when we said the equals 0 here, everything was on this side. But when we equated that to 0 and then we did an iterative formula and singled that x and took it to the other side, we did all that on this, didn't we? Where we're equaling the 0. And that's where the alpha and beta are. They're the roots of the derivative. Yep.
Okay.
Does that make sense now? A bit more on that one?
I didn't get the second part. I understood the first bit with all of the quotient rule, but
Yeah.
with the graph and the iteration formula, I didn't understand why we used the derivative formula.
So if I had y is equal to x squared minus x minus 12. So this is a quadratic, so it'd be x minus 4x plus 3. So that's equal to 0. And where does it equal to 0? Where are my roots? They're going to be at 4 and minus 3. So that's just going to cross at minus 3 and 4, and that is going to be where I'm going to smile. So when y is equal to 0, these are the roots. And we can plot all of this because it's all on one side. But when you've got a complicated formula, we do an iteration formula. Say I wanted like a cubic. I had 3x cubed plus 2x squared plus 3x. I could maybe, and equal to 0, I could maybe make that x the subject. So I could take everything to one side and say 3x is going to be minus 3x cubed minus 2x squared, and then just divide by 3. And now when I've got an iteration formula, I can't just plot this and look for where it crosses the x-axis. I plot this and I plot this, and y is equal to x is always going to be like this. Now, this is going to be some negative cubic curve, so it's going to go down, wiggle down, and we might have a root here. So where they both equal is going to be when everything's to one side, where it would go through the x-axis. So when I'm looking for this point where the two cross, that is going to be the same as when I plotted the original positive cubic where that had its roots. Like these aren't the proper graphs, but I'm hoping that you can just see what I'm trying to get at. So because we've separated it out and you've made x the subject, you're always going to be drawing y equals x, and then the remainder, what's on the other side, is going to be the other graph. And then you're going to estimate what a root is. We can see the roots are where the two cross, the intersections where they cross. And then we're saying that the first estimation of the root, so you go up to the curve and that would give you a y value, but that y value, if we trace it to here, because that's the line y equals x, that's the same x value, which will be our next estimation of our root. Then take it up to the curve, which will give us the same y value, which if we go along will give us the same x value, and you home in to get to the root, and you home in and it cobwebs or staircases to the root. Does that explain it a bit better?
Yeah. What makes something an iteration formula specifically?
An iteration formula when you've got everything equal to 0, and then you start singling out an x and making that x the subject. So like I did here, so I could make any of these x's the subject. On my thing that I've just made up there, I could make this x the subject, and I could have 2x squared is equal to minus 3x cubed minus 3x. And then I could divide that by 2 to get rid of that, and then I could take the square root, and I would be plotting an x with that and seeing where they meet rather than where the original cubic hits the x-axis. So any iteration formula, you make x the subject, and then you choose a starting value as an estimate of the root, probably because you've plotted the graph and you can see where the two meet. So you start with something nearby and you try to put this in your calculator as your first estimate will be your x1, and this will be your x2, or that will be your xn, and that will be how to get them to the next one along.
Oh, does
Yeah.
the like that one on the graph need to be in between the two values?
No, it just needs to be close to one of the roots. Doesn't need to be, because sometimes you don't even have two roots, you only have one. It just needs to be close. And the choosing of the first initial value, sometimes see that one homed in on this root. Sometimes just the way the graphs two relate, sometimes they don't home in on the root, just all about choosing the right one. Because choosing another one, so if we chose one down here, that would go to, see, that would go away because that would go to the curve. And so choosing a value here would be close enough to home in on the alpha.
Oh, so do you need two different starting points for each
Yeah,
root?
well, they normally get in this type of question, they normally always give you the starting value. Like you don't usually have to have a starting value. They'll give you the first one to use.
Oh, okay.
They give you that one. Have you done this have you done this subject at school, or maybe
Yeah,
you
but
didn't spend too long on it?
we did it too quickly.
Yeah, so you haven't yet. Yeah. Okay. Can anybody see us the two chats? Can anyone have a quick look and see what the other chat thing was before I move on to the next question? Anything to ask? No, is there nothing there? Right. Let's go on and have a look at another question. So just picked here, because usually they do give you when you're going to use, well, I won't say what we're going to use here, but what do we think? Georgie, what do you think you might do to
Is it substitution?
substitution? Now, I think at your school they do encourage you to use your own substitution, but usually in the exam it tells you to use substitution. Now we can see we've got two things timed together, so we might think it's by parts, but they're both algebra, so we couldn't really do it by parts, could we? So what should we have as our substitution? Will we say u is equal to the x plus 2? What your school said to choose, how to choose your substitution. You could either have x plus 2 or rooted, or just the inside function of that kind of main function. That's normally what you would use. Is that what you would do, Georgie?
Yeah, I would do
Yeah.
the x
Yes,
plus 2.
do. So what would be your next thing?
Differentiate it.
Yeah,
So just is equal to 1.
1. So that tells us that du, well, we'll cross multiply and take that d up. X is equal to dx. So what else do we need to do? Should we do the limits next? Ritesh, what we're going to do for the limits when x is equal to 0, u is equal to
2.
2, when x is equal to 2, u is equal to 4.
4.
So we've got
Yeah.
a substitution for that. We've done our roots. We just need to get this bit here. So go back to my original substitution, and u minus 2 is equal to x. And I actually need 2x. So 2x is going to be twice times that. So now I've got all my bits. Let's go and integrate. So we're going between 2 and 4 of 2u minus 4 times u to the half. Yeah. So, Ink, what would we do next?
Substitute the 2 in.
We haven't integrated yet. What do you
Oh,
need
oh,
to
sorry.
substitute?
Half of
Because we've now got this multiplied by this, let's multiply that in.
2u to the half.
Well, you've got u to the 1 times u to the half.
Oh, sorry, 3/2.
3/2
And
minus
then
4.
4u to the half.
Now we haven't integrated yet. Georgie, do you want to integrate? Now, when I integrate, go to big square brackets.
So it'd be u to the 5/2.
2u to the 5/2. Divide by the new power, which would be 5 times over 2, but that 2 is going to come off
cancel.
and go there.
And then it would be u to the 3/2 divided by 3, and then it would be 8 on top.
Yeah. 2, 2, 4. And now put in our limits. So we've got 4/5. When u is 4, we've got here 2, which is going to mean square rooted. So 4 square rooted is going to be 2, and 2 to the 5 is 32, minus 8/3. 4 square rooted is 2, 2 cubed is 8. Minus, let's put the 2 in. So we've got 4/5. Now it will just be 2 to the 5/2. Now looking where I'm going, I need a root 2. So instead of writing that as 2 to the 5/2, 2 to the 5/2 can be written as 2 squared times 2 to the half, which I know 2 to the half is root 2. So when I add those two together, they're going to be 2.5, which is 5/2. And then that 2 squared, we can work that out, which is 4, which can join in with that 4/5 on the front. Everyone happy with that? Minus 8. Ritesh, can you do the same on u to the 3/2? Putting 2 in.
Sorry.
So, do you understand what I've done there with the 2 squared and 2 to the half?
Yeah.
Yeah, so do the same here. So I'm putting 2 to the 3/2. How could I else
Yeah.
could I write that? It's times 2 to the 1 times 2 to the half.
Oh, right. Yeah.
Yeah,
Yeah.
times 2 times 2 to the half. And then once we've kind of, brought some numbers out, they can join in here.
Mhm.
So that's times 32 minus, just put that as 64/3. We could sort those numbers out. Minus this 2 squared is going to be 4, so that's going to be 16/5 root 2. 8 times 2 minus, I've lost a 3 on the bottom, 16/3 root 2. And now hopefully we'll sort it all out, because I could change the denominator to 15, and we're going to get this. So if you go on your calculators, anyone tell me what this first bracket comes out to be? 4/5 times 32 minus 64/3.
64/15.
Yeah, good. Now, because I've got this now as 16/5 root 2 minus 16/3 root 2, can I just sort that out? 16/5 minus 16 over 3 of the same thing. Is that minus 32 over 15 root 2. Can you just see, because I'm collecting in terms of root 2, just did 16/5 minus 16/3 on the calculator. And so we can see that this on the top, the 64 over, can be a 2 times the 32. And we can take 32 over 15 out on the front. And we're going to have a 2. And this minus minus will make a plus. And we've got what we were after. Yeah, so see the substitution and sorting all that out, but sometimes it can be just like doing little tricks to manipulate to try and get you, because the idea when you're trying to have exact values is try not too much to go on your calculator. I mean, that probably would have been okay on your calculator. Yeah, everyone okay with that one? Let me go look at another one. So this is another substitution one, but then we're going to go on to do some differential equations. So it tells us this time, which is what normally it tells you to do more often, 4 minus root h, which we can see as that denominator, to show that it's going to come out to look something like this. So let's write our u is equal to 4 minus h to the half. So, Ritesh, do you want to differentiate for us?
So you'd get a, just a minus half h to the minus 1 over 2.
Good. So we want to substitute and get what dh is. So I would rewrite this as minus 1 on the top over 2 root h. And my substitution was that u is equal to 4 minus root h. So on the bottom, I have got that root h is going to be, well, I could leave that minus there and get u minus 4 is equal to minus root h. So this is going to equal a minus 1 over 2. What is our minus root h? A u minus 4. And I could maybe lose that minus because I've got minus root h on the bottom. So my du, if I cross multiply, is times by a 2u minus 4 stands for a dh. So 2u minus 8 du is equal to dh. Like in the last one, the du and dx, they were equal, but I need to have what stands for dh in terms of u. Everyone okay with that?
How did you get the first line again? The
Which line but you're just differentiating. So if u is equal to 4 minus h to the half, du by dh, well, 4 differentiates and goes out. We're going to get power down minus half h, take 1 off, minus a half. So the minus a half means it's going to go underneath. So this is just going to be minus 1 over 2 root h. Now, what's our substitution? Our substitution is that u minus 4 is equal to minus root h. And really, this minus on the top, I can say that that's 1 over minus 2 root h. So this is just going to be 1 over, well, the minus root h stands for our u minus 4. Yeah.
Oh, and how about the du and then 2 bracket u minus
Yeah, so
4?
now we've been just manipulating, and been just manipulating this side to replace that h in terms of u. And now we've got our du by dh is equal to that. And then we're just going to cross multiply, take this up and take that there. So
Okay.
2u minus 8 du is equal to dh. Yeah, so now we can put the substitution. We haven't got any limits. So put in our substitution back in. We're going to be integrating our 2u minus 8 all over what was on the bottom. That is just our u. And we're going to be doing du. So now how we're going to actually integrate this. Ritesh, are you okay up to here?
Yeah.
So now what we're going to do, now we've done our substitution, what are we going to do to try and integrate this?
So make it turn into separate separate fractions. So
Exactly.
2 minus 8 over u.
Yeah, so those u's will cancel, and we're just going to be integrating 2 minus 8 over u. So now do the integration.
So would that be 2u minus 8 ln of u?
Yeah.
Plus c.
Yes.
Or
Well, let's call it c for now. And then
yeah.
what was u, because we've not got any limits, this is the type of one where we have to now, we've done the integration, we've used our substitution, we now need to replace what was u. So u was the 4 minus root h. So this is 2, 4 minus root h minus 8, the ln of 4 minus root h plus c. So, Georgie, what we're going to do now?
Expand out the
Front bit,
yes, 8 minus 2 root h. And then
So we've got a minus 8 times that ln, which is this bit. We've got a minus 2 root h, which is this bit, but we've kind of got an 8 and a c. So what are we going to do now? Now c is just a constant. Remember when we're doing some differential equations, any other constants can now just be bunged in together with the c. So we can move that 8 and say, call the new constant, which is the constant of integration plus a bit more, as long as it's just like a constant, not a variable, they can just all to go together, and that can be our k. So this is going to be, just writing it in the order that they're asking us in the question, minus 8, the ln of the 4 minus root h minus 2 root h plus a k, where k is some other constant that joins the constant we've got from integration with the 8. Yeah, which doesn't seem quite mathsy, but that's what we've got to do in order to get where we're going. And it doesn't seem right that you just bung things together when we've got an 8 there and that we can use the 8, but just put all the constants together. Does everyone see that? Yeah, is that okay, Georgie? Do you get that now?
Yeah.
Yeah.
Yeah, that makes sense.
Okay, so the next bit, a team of scientists are studying a species of growing in the trees. The rate of change of the height of the tree of this species is modeled by this differential equation, where h is the height in meters measured after the tree is planted. Find, according to the model, the range in heights of the trees. So, what would you do with this? Got a differential equation. We can see it's kind of using bits and pieces that we've done in part A, which might be useful in a minute. But when you're planting trees, what sort of range? Do trees have negative heights? What's the starting of the range of the tree going to be?
Oh, it has to be more than 1, more than 0.
More than 0, yeah. So you've got to like be thinking in the common sense of things. Now, because we've got a thing here, which is whenever we see dt on the bottom, it is how the height changes with respect to time. So although we've got a differential thing here, depending on how long the tree's been planted, so t represents the time, this equation is going to give us the rate. Now, when we talk about rates, rates have their differentials, but because they're differentials, we can have max and mins. So if we equate that to 0, that's going to give us a turning point, because this model is going to predict that maybe we might have a turning point and therefore the tree's not going to grow anymore. So to find the range of the height of the tree, we can look at this dh by dt. We know that the trees are going to start with height 0. And then we can have a look at what this thing's going to do. So, any ideas what we can do? Now, anything top and bottom equal to 0, we can just cross multiply and get rid of that 20.
Oh, you equaled the top one to 0 and then
Yeah, and then the t to exponential, all exponentials are like that. So this is only going to equal 0 when 4 minus root h is equal to 0. So we're going to do 4 is equal to root h, and then square both sides. 16 is equal to h. So the range of the heights of the trees are just going to be bigger than 0 and up to 16.
Oh, okay, I see now.
Yeah, everyone see that? Could we equal 16? Yeah, when h is equal to 16, that's going to equal to 0. So yeah, so 16 is going to be the maximum height of the tree. Yeah. Okay, one of the trees is 1 meter high when it was planted. According to the model, calculate the time this tree would take to get a height of 12. So, Ritesh, what do you think we're going to do now?
Rearrange it for t.
But what we're trying to find, we're trying to calculate the time.
Is t not the time?
T is
Or
the time, but
yeah.
this is what we've got here with our dh by dt.
Oh, do we want to integrate
We
first?
want to do separate the variables, and we need to solve this differential equation. So it's not, it doesn't say in the words of the question, solve the differential equation, but that's what we need to do to get the t. We need to solve the differential equation. So what do? We have to cross multiply. We're going to go and take the 1 over the 4 minus root h dh on one side is equal to RT to the 0.25 over 20 dt, because then we're going to be able to get T as a subject. So
Yeah.
even though it didn't say solve, that's the thing that we need to do. And quite often, like we've used this part A, we should have noticed that bits of A were in here, and it was kind of obvious that we were going to be integrating, because that's the way these questions kind of go.
Okay.
Right, so
So
on the so on the left, we're going to
that
go.
would integrate to,
Well, that is what we've just done here, isn't it? We used our substitution, so we can just copy that down.
oh, right. Yeah.
So we did that in part A. So all we need to do is integrate in part B. Now this, not part B, in the right hand side, this T to the quarter is, we can write it as that. The 20 on the bottom is going to just join in. So what happens when we integrate with a power? It's going to go to T to the
5 over 4, and then 4 over 5 at the front.
4 and 5.
Mm,
And we've also got our 20 underneath.
Wait,
Yeah.
would it not be a 4 on top?
Oh yeah. Divide by a new power, 5 over 4 times the 20. Yeah, that was my mistake. Sorry. Okay, and then we've already got a constant of integration there, but we'll need a plus C there.
Yeah.
Yeah.
So
So
would you
sort these out.
times
Yeah, 5 times 20 is
everything?
100. Let's just sort that out and divide by the 4. 4 divided by 100, we're going to have a 25 there.
Would you
Now,
times everything on the left by 25? Or
well, first of all, the way these questions go is that you need to use some of the information to find our constants.
okay. So, oh, you want to find K first, right?
Yeah,
Or
yeah. Now,
so
this C here, we can maybe just put it all to one side and just like that K there, we can just maybe say that that is a bigger K.
K plus C.
Yeah,
Yeah.
and
Okay.
bung them all together.
Yeah.
Now it says what's the initial information, because we need to find the constant. One of the trees is 1 meter high when it's first planted, so that's telling us H is equal to 1 when T is equal to 0. So we need to put that in. So that's telling us if T is 0, we're going to get 0 there. We're going to have minus 8 the ln of when H is 1. That's going to be 4 minus 1, which is 3, minus 2 times 1, which is 2, plus K is equal to 0. So K is equal to, take these minus terms to the side, 8 the ln of 3 plus 2. Yeah.
Okay. I got
And now we can times put
10.79. 10.79.
Yeah, let's just leave it like that, because now our equation is minus 8 the ln of 4 minus root h minus 2 root h plus rk plus 8 ln of 3 plus 2 is equal to our t to the 5 over 4 divided by 25. And we want to find the time when h is 12. So now we need to put h as 12 in our left-hand side, get that on our calculator, times it all by 25, cross multiplying, and then in order to get t on its own, we need to raise this side to the 4 over fifths, and then this side to the 4 over fifths. So all that needs to go in your calculator with h being 12.
Yeah.
So if we do all that, your t should come out to be 75.5. years. So it's going to take 75.2 years to get to a height of 12 meters.
Okay. Yeah.
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 I'm a bit lost. Could you explain the part where you split up the equation and had dH on one side and dt on the other?
Have you done solving differential equations?
Um,
Have you done first? It comes usually at the end of the integration chapter.
I think we have finished it all, but I just can't
So
remember it.
whenever you're given any equation that has a differential or derivative in it, this is going to be a first order differential equation because it has just got the first derivative in. So how do we solve? What you do is you have to separate the variables. So this dH by dt here is not a fraction, but it can operate as a fraction. And whenever you see derivatives, then they're either on top of each other like that, or they are something with respect to h that we're going to integrate and something dt. So these dHs and dt's either operate on top of each other or at the end of an integral. So they never operate just by themselves. That's the only way we can write them. So what we need to do is treat it like a fraction, and you want to get the dH and the dt in the numerator position at the end of what we're going to integrate. So the one here needs to come up here, which tells me this side of the equation needs to be the t side, and then this 4h, that needs to cross over this side to be on the h side. So you separate the variables and get the h's on its side to make the dH in the numerator position, and get the dt and the t's on the other side. Yeah, do you understand what I'm on about?
Yeah.
Yeah, so because I know that I've just differentiated that, it's really handy that that is just going to cross multiply and come over here and go 1 over 4 minus root h dH, which will then leave everything else on this side to just be t to the 0.25 over 20 dt. So that's just separating the variables, and then integrate this side, integrate this side. The integral of this we had in part A, and integrating this, we just treated it as t to the quarter, add 1 on, divide by the new power. So adding 4 quarters on was 5 quarters, and then divide by the new power, put that, and then the 20 just joined it. 5 times 20 is 100, and cancel that, just left us with the 25 on the bottom. Yeah.
Okay.
And then we used what we'd done in part A to give us what the integral was on the left. Yeah, any more questions on that one? Georgie, were you okay? Where did you get to?
Yeah, I got it. I did it in my calculator.
And
and
did it come
rounded.
out to that?
Yeah.
Yeah. And would you have known that that's what you had to do for part C?
The
To
yeah,
do
I
differential
spotted the
equations.
differential
Yeah,
equations.
yeah. So whenever we're trying to, so it doesn't tell us to solve the differential equation, but we had to get time as the subject. But if you, Ritesh, if you're just making that t the subject, what are you going to do with this business here? How are we going to kind of make that? So yeah, this, once you've done a few more practice papers and stuff, and seeing this type of question a bit more, you'll kind of know that the flow of this needs to be that we need to solve the differential equation. And always the way it kind of, the routine of it is separate the variables, do the integration. You're going to lump your constant just on one side. So when we had this plus c, and we might have a plus c, bung all your constants together. Now normally you do collect them on the right, but because we had that k from the previous, we just kept it there. But it wouldn't really matter if you'd kept it over there, it would just come to the other side and be a minus. We could keep it there, whatever. And then you're given, in order to go from your general differential equation, so when we've got constants that we don't know, that's going to be a general differential equation. You have to use some information. Remember when you used to do proportion in GCSE, and something was proportional to something, and then you'd always have your k, your constant of proportionality. You'd given some information in order to find the k, and then that's the connecting formula. So when you're given some information, one of the trees is planted, when it was first planted, it was height 1. That information allowed us to find our k, and then once we've found our constant, we could then go on to use the particular solution to the differential equation to find what t was. Yeah, so I was going to do, I had another one there, but we'll leave it there. That's another differential equation. Maybe I can just copy this and send it in an email with the link to the recording, and then you can maybe have a go at that. We can see how you get on with that next time. Okay, and I was going to do some after that. I had a couple of stats questions to have a look at as well, so we can do those next time. Any requests for what you'd like next time? We could do some more differential equations, because there, I can do that one that I've got lined up. Anything else from anybody?
Could we
Can we do standard normal
You want
distribution?
normal? Yeah.